आजा। ऐड तो क्या फिर से आ। जल्दी आ जल्दी। वेटिंग फॉर आया आया ये रहा। सोया सोया।
ये सुन, अरे तूने ये कर लिया?
मैं अभी देखूंगा।
अच्छा हाँ, मुझे भी तो क्लास कर लो। लैपटॉप नहीं क्लास तो कर रहा है।
काय रे होय रे नी हां नाही करूया तो पिला मैं बस लैपटॉप ओरड के नहीं बस
अरे
काय होतो ना बाबा को आणले खेळू ना
1 मिनट में अभी लैपटॉप में बाबा
निकाल
लैपटॉप ये बड़ा होता है
सीधा खोल दीजिए। अरे कौन है?
देखिए
सामने
तो ऐसा होता है
मैंने उसी क्लास में बोलते हैं।
ये तो क्लास है वो बताता है मोबाइल को क्या कर अरे मेरा कुछ करना
मैं आपको काटती
ମାନେ ୟୁଟ୍ୟୁବ ମୋବାଇଲ ଭିତରେ ଫରକ କଣ? ଆନନ୍ଦ
तूने वो वीडियो देखी है?
कौन सा वीडियो?
वो जो था
ସେ କୋଉ କଥା
पहले
ମାନୁନି
स्टार्ट में
ମୁଁ କୋଉ କୋଉ ଯଦି ବସି ନ ପାଠ ପଢି କରୁ ସେତେବେଳେ ମୁଁ ଦେଖେ ଏମିତି କୁଟା ମାଡ଼ ହଉ ସେ କରୁଥିଲି ଏମିତି ପିଟିଲେ ରସ ବାହାର କରିବେ ମୁକ୍ତି ଦୂର କରିପାରିବେ କପड़ा की लगाम से करो
पाठ पढ़िया कहीं
मुझे देखी केते पाठ पढ़ी हाँ खेलू खेलू पछली तो ओंकार का दुकान हुआ मुझे पछली पछली को चीज दे दो हां ये पछली थोड़ा से कौन से जी ये रेट तो ये रेट पाठा पाठी किसी नहीं केता कर 110 टका
रुक जा। ये क्या खोल लिया तूने? ये कोई देख भी नहीं रहा, हम लोग लाइव है भाई। मैंने देखा 28 सब्सक्राइबर्स, समझ रहे?
देखा है देखा।
एक दिन में
लाइट फाइट इलेक्ट्रिसिटी सब डिजाइन हम देखियो सुपर डिजाइन वो डिजाइन करेंगे मतलब सिंपल है कुछ मैंने इतने ही है हां सेठी हम देखी काय सारा एस्टिमेट और एस्टिमेट का बात करता है सब कुछ था वो अस्सी के तो अस्सी वो अस्सी के आखिर संडे का एग्जाम है हां
हिंदी मत कर लेने दो
मत कर तो कोई तो खाली कोची बारे नहीं मते ना अपन बारे में देखी तो कोई उसी बारे में इंग्लिश से ना बड़ा दादा मुझे बारे कहेंगे इन बारे में देखिए
यही तो बोल रहे थे।
क्या बने
So first of all, thank you. Hello.
ଏଇଥିପାଇଁ ମୁଁ ମ୍ୟାମ୍ଙ୍କୁ ଡାକି ଆଣି ଦି ଜଣ ବସି ଭିଡିଓ କଲ୍ କରୁଛି ନା ଆଉ କ୍ଲାସ୍ କରୁଛି ଆଉ ଅଡିଓ କଲ୍ ଲାଇଭ୍ ଚାଲିଛି ଲାଇଭ୍ ଡେଲି ମୁଁ ଛୁଟି ରହେ ଲାଇଭ୍ ଡେଲି କାଟୁଛି
हाँ बहुत ठीक है सफर
ମୁଁ 3 ବର୍ଷ ୟୁଟ୍ୟୁବରେ ଲାଇଭ୍ କରୁଛି यूट्यूबर लाइव बस कुछ टीवी पे
एक सेकंड रुक भाई, मैं अपना 10 करोड़ का स्पीकर लगा रहा हूँ।
क्या 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 हाँ
10 करोड़ का स्पीकर।
हाँ बस बस बस
मान बताए क्या? ए साउंड नहीं आ रहा है।
डायरेक्ट यार तूने क्या भेजा रे
I am also very excited with the
ते ये वस्तु से काम नहीं पकेला पूरा है ना तो अब समझ ला तो आखिर पानी है माने ये होती तो तो लोग मत इतने ये वाले दिन जो
exercise do you have it
माने
YouTube next week
करते हैं यार माने पाए जोग्य नहीं
Again, I want to highlight that this video's main focus is to motivate and inspire the young minds who are eager
start हो
to
गया
explore skills. And we have this unique opportunity today to learn from you that you don't have to be practicing aerospace industry.
I'm Cynthia, so looking forward to the conversation.
Okay, so shall we start?
Yeah, yeah.
Okay, here is the first question. We are all excited to know how did you develop an interest in space and aerospace, and what inspired you to become a pilot?
In terms of diversity, 2012, it's like kind of college. I had opportunity to study this part of the and learn it, and learn about happening. And clear understanding of what
ये साधने
हाँ
एक चीज देख एक चीज देख
advantages and opportunities. I thought like it would be great to build a very strong
to help
education village also the country and also like complete globally. But ISRO is
etc. But
अरे ये हमारा नहीं है
its mandate is not to do business.
हाँ
Yes.
हमारा ये वाला है जूनियर जूनियर साइंटिस्ट वीडियोस में हमारा
जूनियर साइंटिस्ट क्या है? जूनियर साइंटिस्ट वीडियोस
हाँ
कौन सा दिया? स्पेस जैक कलेक्शन रोबोट।
हाँ 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 वही
master class. So let's begin. Let me just share my screen.
अरे बाबा ये क्या मार रहा है? एक सेकेंड
Space Innovation Challenge Master Class. Okay, so your challenge is to design a crystal collection robot. How do you do that? In order to do that, you need to know some basics about
भाई
robots.
कोई नहीं देख रहा
So we are going to learn
काट
about
दे
किसको?
Next, you need to voices. Think about it for a minute.
वाह भाई क्या मार रहे हैं वे मेरा वो स्पीकर देख रहा है खाता
Robot is a special machine that can move around and do things by itself or by following instructions given to it by people. In the
Hello
sense of
everyone. Hope you're
robots
all excited for this.
robot.
मुझे कौन
Robots
सा है
are machines and can do many different things like
हेलो
build cars, exploring outer space.
कौन सा देख रहा है तू
अरे भाई
Now,
तू जो देख रहा है अभी, हाँ भाई
that are special
ये
machines designed to explore and
Welcome
study
to our new
things
tutorial.
from space, such as
क्या
planets,
भाई तू क्या कर
asteroids, and other celestial
देख
bodies.
जूनियर
These robots are often sent to the space by some space
जूनियर
agencies
वीडियोस
like
में चल
NASA or ESA.
स्पेस
Have
स्पेस
ISR
टाइम
or
कलेक्शन
collecting
रोबोट
information and data that help scientists and researchers
Design to travel through the space.
तू छोड़ दे
वो
वो।
कौन सा मिनट है
Just the basic fundamental.
पहले तू जाना जूनियर साइंटिस्ट रिसोर्सेस, ठीक है, फिर रिसोर्सेस टिंकल सीएडी डिजाइन।
ए शुरू से शुरू करते चल शुरू से शुरू कर एकदम शुरू
है
शुरू
ये कौन सा देख रहे तू?
अबे यही तो है
नहीं है,
क्यों तू कैमरा की तरफ move
अरे
कर
सो तू तू वो छोड़, तू हार्ड हो जा, तू पहले जाना सब काट दे, ठीक है, जूनियर साइंटिस्ट वीडियोस, ठीक है,
हाँ
इसको क्लिक कर।
हाँ
क्या आया?
दो एक स्पेस जेट कलेक्शन रोबोट और एक रिज्यूएबल रॉकेट डिजाइन
कलेक्टर रोबोट दबा।
ओके वही तो देख रहा हूँ
अब इसको 3 2 1 बोलते स्टार्ट कर देना, ठीक है, 3
स्टार्ट
2 1 तो पहले स्टार्ट कर दो। इसको बड़ा भी कर सकते हैं, बड़ा कर दो, आराम से देखो।
और देखो
लाइट का चाहिए ना
नहीं नहीं गूगल पे उसको
तेरा पहला ही आ गया
Hello everyone. Hope you're all excited for this master class.
नो मैम
Let's begin. Let
No,
me just
ma'am.
share my screen.
नो मैम
I welcome you all to the National Space Innovation Challenge Master Class. Okay, so your challenge is to design a space gem collection robot. How do you do that?
So we are going to learn about these
We need
three
to know some basics about robots, space gem, etc. So we are going to learn about these things in today's session.
things. Think about it for a
Now,
moment.
let's begin with the first one. What is a robot? Think about it for a
So,
moment.
robot is a special machine that can move around and do things by itself.
So you can see the movable arms that is attached to this. Okay. Now, robots in space. That are special machines designed to explore and study different parts of space, such as planets, asteroids, and other celestial bodies. These robots are often sent to the space by some space agencies like NASA or ESA, such as- or even playing games with asteroids and other celestial bodies. These robots are often sent to the space by some space agencies like NASA or ESA, or we have ISRO to collect information and data that help scientists and researchers to learn more about our universe. There are many types of robots that are used in space. One another example is the rovers, the landers, orbiters, etc. Here in this picture, you can see some robots. So the first one, that is Perseverance, and here you can see the Curiosity robot. And here we have one another lander. This is the Insight lander, and others are all orbiters. Orbiters are robots that travel around, taking pictures, gathering information about the area. So coming to rovers, and that is like a robot that are designed to move around on the surface of a planet or asteroid, taking pictures and collecting samples, similar to the orbiter. But it can move around and it can explore the planet or any astronomical body. Now, tell me what are the major issues they face? These type of robots.
क्या हो सकता है भाई क्या हो सकता है हम
What
लोग
are
भी गेस
major
करो
issues? the space radiation. We have several sources
Yes.
of space radiation, and one example is solar radiation. And we have the galactic cosmic radiation as
Yes,
well
yes,
as
yes.
the Van Allen belt radiation.
सन से जो होता है सन.
Okay, so we'll talk about that. Space radiation is a type of energy that comes from the sun and another sources in space.
Yep.
Spacecraft like International Space Station, the ISS, it has some special areas called the radiation shielding that help protect the astronauts from the space radiation. And I told you about the Van Allen belt, right? So it is the charged particles trapped in planet's magnetosphere. It can also affect electronic equipment and satellites in space. So scientists and engineers have to design them to withstand the radiation. Our space agencies monitor the space radiation levels to ensure the safety of astronauts and spacecraft. So, how do you protect your spacecraft? We need something that can protect the entire spacecraft from this harmful radiations, right? That we can do by this multi-layer insulation, or we can say MLA. Okay. So these are the layers like blankets or jackets that have several layers of different materials to keep things warm or cold. This multi-layer insulation can help keep things cool by reflecting the sun's heat away and preventing it from entering. So that's how this works. The MLA. In this picture also you can see the gold color. That is not gold foil, it is the MLA, multi-layer insulation. Now, let me ask you another question. What do you know about Canada? Have you heard about it?
No.
So,
Really.
Canada Arm is a robotic arm used in space by
Oh.
astronauts to help them with different tasks. The Canada arm is actually about 50-meter long. You can see in this picture also the long arm.
मैं बड़ा
It is a
box हूँ.
big mechanical arm that can move and grab things in space. It is made up of different segments that can rotate, bend like the human arm. Okay. This Canada arm is very strong and it can lift heavy objects in space like satellites or piece of the space station. It helps for docking also. Okay, you can see the docking port. So whenever the cargo or the space shuttle comes, the Canada arm will help that space shuttle to attach or for the docking. Okay. Now, tell me what is a let's talk about that. Artificial satellites are launched into space using rockets. Once they reach the desired altitude, they are released into the orbit. So we have different orbits also. It is not in a particular orbit that every satellites or every space robots are moving. So we have different orbits. Satellites are used for various purposes, including communication, weather forecasting, navigation, scientific research, and even spying. Satellites can stay in orbit for many years, but eventually they may run out of fuel or become non functional and need to be replaced. That is actually a very big issue. Once it is not functional, it will become a debris. Okay, so there are thousands of artificial satellites orbiting the Earth right now. Now, in this picture, you can see the first one that is Sputnik 1. Sputnik 1 is the world's first artificial satellite. It was launched by Soviet Union on October 4th, 1957. Sputnik was a small shiny sphere that is measured about 58 centimeter only. That is the diameter. And here you can see another one that is Aryabhatta. Aryabhatta is the India's first satellite and named after the famous ancient Indian mathematician and astronomer Aryabhatta. So this is also launched with the help of Soviet Union. Okay. So these are all about artificial satellites. I told you there are plenty of satellites orbiting right now our planet Earth. Now, tell
Two
me,
all
do
types of
all types of
spoons.
satellites orbit at the same height?
No.
Or do we have different orbits? I already told you about this, right? So these are all not in a single orbit. So we have different orbits. In this picture, you can see the yellow one that is close to planet Earth. This is called a low Earth orbit. Typically, this orbit is in between approximately 1000 kilometers. And the next orbit is medium Earth orbit or MEO. You can see that. This is approximately
Medium
ranging from
orbit.
10 kilometer. The measurement that varies. So this is an approximate measurement of this orbit. And the next one that you can see here, geostationary orbit. This is at an altitude of approximately 35,768 kilometers. So that is the altitude. And we have different satellites that is orbiting in low Earth orbit, medium Earth orbit. Depending on the purpose, it will be in different orbits. Okay. Now, what is the downside of using satellites? Is there any disadvantage of using satellites? Let's talk about the major disadvantage. That is also your challenge. So, space junk. What is space junk? Over the years, space missions and satellite launches have left behind a significant amount of debris in Earth's orbit. So, this debris ranges in size from tiny fragments to larger objects. You can see in this picture also so many debris are there, right? And here we have our planet. So that is in debris. Okay. We have 5,500 tons of space junk up in the sky. That's a load, right? So more than the satellites, more than the space telescope, we have debris that they're orbiting around planet Earth. So depending on the size, we can classify like this. Less than 1 centimeter, we have this many pieces up in the sky. If it is 10 centimeter and bigger, then we have 20,000 pieces. So imagine, even it is a scrap of plane that is going to orbit around planet Earth. Okay, why space junk is a problem? Why we are talking about space junk? Space junk poses a risk to operational satellites, the International Space Station, and future space missions. Collisions with a small debris can cause a severe damage due to the high speeds at which the objects orbit the Earth. In this picture, you can see this is Canada. We already talked about that. Here, can you see a tiny hole? This is actually due to the collision of the space debris. So that made an impact hole in Canada. And in the second one, you can see this is the Hubble Space Telescope. Here also you can see the impact that is created due to the collision of space junk. So it is actually a threat for the future missions, the satellites, whatever there in the sky that is functional. Once it is not functional, then again it is also going to be a space junk. We are not taking the space junk back to Earth. So we need to find a way to reduce all this. Imagine, initially we never had any space junk, right? In this picture, you can see the pale blue dot, that's our planet Earth. And after 2005, you can see it exponential growth. We can see an exponential growth in the space debris. So, what will happen in 2030? You can't see the planet Earth. It will be like covered with white dots. That many space debris will be there in the future. So we have to solve this problem of space debris. How can we do that? Why do you have to do that? We'll talk about that. So I hope you're interested in astrophotography. See this kind of picture. Here we have the North Star. So every stars are revolving around that. It's not revolving around that. It's like moving uh, according to the North Star. Here you can see every stars are moving. So, in order to get this kind of picture, you need to take a long exposure photography. When you do that, imagine something is moving like this. Then the entire photo is doing, right? You won't get the movement of the stars, but you will get some random pieces moving across. Then you can't get a beautiful picture like this. So that is actually the satellite. In this picture, you can see some trails. Can you see the long trails that is moving? When you take a picture, you can see so many satellites, the aeroplanes that is moving. These are 19 Starlink satellite trails post the image during 6 minutes exposure photo. That is actually a very big problem. So, if you need to have a beautiful sky like this, then you have to reduce the space junk and you have to reduce the use of the satellites and everything. We have to minimize, we have to reuse, and we have to reduce the space junk. Okay. How can we solve this issue? You have to think about it and you have to come up with an idea. We need to remove all the space junk that is up in the sky. But we need a special technology to do that, right? We can't go there and grab everything back to Earth. We need some robots that will be able to go there and collect the junks, and we need to find another way to dispose also. So that's how we can reduce the space jam up in the sky. So now it's your turn to create and design something that will be removing all the space jam up in the sky. Okay. So hopefully see you soon with your successful project. Thank you so much everyone. Thank you for your attention.
WhatsApp चलाया
না এই দেখুন উপর তলায় ধরো গুগল টুকু ছিল নিচতলায় আমি তুলেছি হ্যাঁ দুটো এসি যেমন টুকু দরকারই নেই এটা নিচে আরাম করে যায় লাস্টের থেকে তাই করি উপরে গুগল টুকু ছিল নিচে আমি তুলেছি বহুত রোজ এখন খাটায় আমার কোনো ভালো লাগে না হ্যাঁ
स्ट्रीम पे चल रहा है
খালি দুটো গলা দিয়ে করে দিই দুটো ট্রেনার আছে কিছু ঢুকাবে ক্লাস পৃথিবীর শেষ এটা হ্যাঁ
व्हाट 34 में लगा वीडियो एंड्रॉइड इन दिस एक सेकंड मुझे इसको बस कंप्लीट करना पड़ेगा तो फिर मुझे पूरा देखना पड़ेगा पूरा कंप्लीट करना पड़ेगा रजिस्ट्रेशन तो हो चुका है कितना बार करूँ ऑलरेडी रजिस्टर्ड है अब I already see this video so MS space jump collection robot mark is completed because मैंने इधर तो देख लिया फिर ये reusable rocket design 19 मिनट का इतना बड़ा वीडियो है ये तो हाफ हाफ करके कनेक्टेड ही है तो लेट्स स्टार्ट भाई सब क्या निकाल रहा है भाई आग निकाल रहा आग
Hello everyone. Hope you're all excited for this master class. So let's begin. Let me just share my screen. Okay. I welcome you all to this National Space Innovation Challenge Masterclass. So let's begin. Your challenge is to build a reusable rocket, right? How do you know how to build a reusable rocket? So we need to know some basics about the rocket that we are going to do in this session. Okay, so let's start the session with a basic question. Tell me, what is a rocket?
A
Think about
rocket
it
is
for
a
a
thing.
moment.
Yeah, rocket is thing that go and research about many things in
So,
space.
rocket is a device or
It has
vehicle
gases
that
go
propelled by the
in
ejection
one
of
direction.
exhaust gases produced by the combustion of onboard propellants. So, in this rocket, you can see here we have boosters and here we have this fuel tank. In that, we have the propellant. It can be either solid or liquid. Especially this kind of vehicle is designed to travel through the space. Okay, so that is the basic fundamental definition of the rocket. Who invented rocket then? The earliest records of the rocket-like devices can be traced back to ancient time, particularly in China, around the 9th century. Okay, so they were using gunpowder inside this kind of rockets. You can see here. So, what was the purpose of this type of rockets? So, Chinese engineers created fireworks, which were essentially small rockets that produced colorful explosions and loud noises. Here you can see the picture, the first one. So, that is the earliest purpose of this kind of rockets. And we have some other purposes also. They also had powerful rockets called fire arrows, which used in warfare. Even in India, we used that kind of rockets for this war. So, here you can see one example of a fire arrow. See, this is actually a weaponized rocket. In the end, you can see this board attached to it. Can you see here? This type of rockets are used in war as well as festivals. So these are all about ancient time. Okay. Now, the field of modern rocketry was revolutionized by the Ukrainian scientist named Konstantin. It is happening in late 19th and early 20th century. And in the early 20th century, an American scientist named Robert H. Goddard, he conducted extensive experiments with rockets and made significant contribution towards the field. He developed and tested various rocket designs, demonstrating the concepts of using rockets for space exploration. Okay, so now let's watch a video of the modern rocket. Are you ready? Okay. So here you can see one rocket that is in the launch pad. It is going to lift off. Okay. Here rocket uses propulsion to generate thrust and propel itself through the air or in vacuum of space. Here you can see the gases that is expanded through the nozzle. So this is how the rocket that will push forward in space. Now, how does the rocket push forward itself in space? How is it happening? Anyway, we have gravity there. The gravity that is always pulling any massive object towards the center of the earth. But how has it managed to go forward and escaping our atmosphere? Let's talk about that. So this can be explained using Newton's third law. Here you can see. So imagine you have a balloon. It is not tied here. Okay, so whenever you open that edge, what will happen? The air that will rushes out. And here we have a balloon that will move forward whenever the air that is coming out of this area. Okay. So here you can see that air rushing out is the action force and we have the reaction force, that is balloon goes forward. So the definition of Newton's third law is for every action there is an equal and opposite reaction. So we are talking about the rocket that is pushing forward, right? So in the case of rocket, you can see here every action has equal and opposite reaction. Then in this case, the action that is the ejection of gases. Okay. And the reaction is the moving forward of the spacecraft, the rocket. So this is how the Newton's third law works. But we are not only depending on Newton's third law, we have some other laws of motion also. Okay, now let's talk about how does the rocket works. I already told you we have several other laws. So especially Newton's three laws we are using in this scenario. Okay. So here you can see the first one, that is Newton's first law of motion. In this picture, you can see the rocket that is staying still on the launch pad. So if it is staying still, we are not providing any external forces, right? That means it will continue to be in the state of rest toward the time until we are acting some other external force upon it. So that is Newton's first law of motion. And we are using second law of motion. So here you can see that the first rocket. So this is our first rocket. It has small mass. And second we can see one rocket that has larger mass. So you know that gravity depends on the mass. If it is less massive, the gravity will be less. If it is large, then the gravity will be more. Okay. So here we have this larger mass rocket, and imagine it should have the same acceleration like the small mass rocket. Then what we can do? So we have to give twice as much as the force must be applied to the second rocket. So then only the acceleration will be same like the small mass rocket. So this is second law of motion, or we can say F is equal to ma. Okay. So mass and acceleration, that is directly proportional to the force. If acceleration should be constant, then the force is directly proportional to mass. Okay. So third law of motion we already discussed, that is every action has equal and opposite reaction. So these are the three Newton's laws of motion that we are using in the launch of rockets. Okay. Now let's talk about the rocket structure. Here you can see that the first one, that is a structural system. So we have the cylindrical shape and we have heat shield also. It is propelling through the space, right? It is through the vacuum and through the air. So it should have some heat shielding substances on the top of this uh, structure. So this is structural system, and here we have our payload system. Okay, so the payload is the part of the rocket that carries the cargo such as satellites, scientific instruments, or spacecraft. It is usually located in the upper section of the rocket. Here you can see. So this is our payload system. Okay, and here we have a shape. This is our nose cone, right? So this shape is called the nose cone. Okay, so it is sharp enough to move through the air and escape our atmosphere. And we have something else that is called the guidance system. Here you can see. The rocket uses guidance system to control the trajectory and direction. These systems include sensors, computer, and control mechanisms. So that is our guidance system. And in the end, you can see we have a propulsion system. Okay, so I told you the propellant either can be solid or liquid, depending on that the shape or the structure will be. And here we have this combustion chamber, and here we have this nozzle. So this is called the nozzle. So through the gas, dust, everything will come out. And also you can see in the rockets we have the fins also. So that is part of the structural system. So these are the four major systems of rocket, that is structural system, a guidance system, payload system, propulsion system. Okay. So I told you about the nose cone. Here in this picture you can see nose cone. That is the shape, right? Shape of the edge. So it is directly proportional to the drag, the nose cone shape. Okay, here you can see these are the base shape. Okay, so these shapes is suitable for moving through the air. Okay, so these are the burst shape because it have the high drag. In the picture itself you can see it has more surface area, so the drag will be more and it is considered as a burst shape. And here you can
Wait a second, guys.
see the surface area is less and hence we have this low drag and it is the base shape. So most of the rockets will have this type of shapes. Okay, now how it balances against the wind? Okay, let's talk about the rocket aerodynamics. So here you can see, here we have a rocket. Can you see here? So this rocket, in the center you can see a pole is attached to it, right? A rod. So that is through the center of gravity. So this is our center of gravity point and through which we attach the rod. Okay, that means it can freely rotate, the rocket. Okay. So if we have some wind, then it will pass us through like that. Imagine the wind direction is like that. It will move to the towards the direction of the nose cone as well as other parts also. Okay. Now, can you tell me where is the wind resistance high or the air drag that is higher? Can you guess from this picture? Okay. So I'll explain that to you. So the wind resistance is more towards the fins. Here you can see the fin structure. There the wind resistance is more and the less wind resistance is at this end wherever our nose cone is. So what is happening here? Why the wind resistance or the air drag is not uniform towards the structure? So what is happening here? Okay, so the air drag and the surface area is related. So in the edge you can see we have the fins, right? The fins is contributing more surface area, hence the wind resistance will be more in that area. Okay, so here at the nose cone we already talked about the shapes. So this is actually very sharp and the surface area is less. So here we have less wind resistance. Okay, so now considering all this, now we can say that the center of pressure will be acting at this point. Okay, so that is the point where all the wind pressure balances out. Okay, so that area is called the center of pressure or we can say C. So here, wherever this rod attached, that is center of gravity or we can say the CG. So both are at two different points. Okay. So I already told you the center of gravity and center of pressure that is not coinciding. So here we have the center of gravity that is our CG. And here you can see the star that is center of pressure that is towards the fins. So CP should always closer to the fins than CG. And what about the center of gravity? So it should be closer to the payload. So this is the basic aerodynamics. Every rocket should follow this. Otherwise, the rocket will not have stability. It won't move properly in one direction. Okay, so I already told you about CG and CP. So imagine our center of pressure is at the center. So it can be at the center. It should be closer to the fins. Now, how can we change the CP towards the fins? Can we do something? So, in order to do that, I already told you CP is directly proportional to the surface area. So, if you increase the surface area of the fins, then the center of pressure will shift towards the fins. You can see here. Now, it is not at the center, but it is towards the fins. Okay. Now, consider the case of CG. It is also in the center. It should not be there. It should be closer to the payload. So now what can we do to shift the center of gravity to the payload system? So we can add some weight in the payload. Then the center of gravity will automatically shift towards the payload system. Okay. Otherwise, we have one more option in the case of center of gravity. We can lengthen the structure. So if the length is more, then also the center of gravity will shift. So that's how we change center of pressure and center of gravity. Okay, so now your challenge is to design a reusable rocket. How can we make a reusable rocket? So we talked about propulsion system, the structure, the nose cone shape, the fins, center of gravity. We talked about so many things. But we have one major challenge. So we will talk about that. So reusable rockets have the potential to revolutionize the space industry by making space access more frequent, affordable and sustainable. But this requires a special design that allows the rocket to slow down and control its descent. You can see here in this video, right? So we have to be able to control its descent. That's actually challenging. Okay, so this concept aims to maximize the utilization of rockets hardware and minimize the need for manufacturing new rockets for each mission. Okay, so the challenge is descent. So vertical landing. Okay, here you can see this is the vertical landing of the helicopter. This is one of the prominent features of reusable rocket. It is the ability to perform the vertical landing, and here you can see how the helicopter is landing vertically. So we have to make the rocket also land vertically. That's the biggest challenge of the reusable rockets. Okay, so what fuel is used in rocket? Let's talk about that. So it can be either liquid propellant or it can be a solid propellant. Okay. So it's about the propulsion system, right? So we have this liquid propellant as well as solid propellant. So in a liquid propellant, we have a fuel as well as we have an oxidizer. So in the liquid propellant case, we have both, that is in the case of liquid. And in the case of solid, we have the solid fuel and oxidizer. So depending on that, the shape will also changes. So this is the propulsion system. And here you can see we have different chambers for fuel as well as oxidizer. So you can see the red color chamber is for the fuel. It can be the solid or liquid. And here we have the oxidizer also. And both fuel and oxidizer that will come through the pipes, and here it is reaching the combustion chamber. Can you see the combustion chamber here? So where the ignition starts, and through the nozzle, the gas, dust, everything that will come out. So that's how the rocket that pushes forward. Here you can see in this picture the exhaust gas and fire that is coming out through this nozzle. Okay, why oxygen is required? I told you we can have liquid oxidizer or a solid oxidizer. Why oxygen is required? Oh, so let's talk about that. Oxygen is very essential for burning. So imagine a candle is burning very freely. Okay, so now we are going to cover the same candle with a lid. Okay, so the candle will burn for 2-3 seconds because it will utilize all the oxygen that is inside this glass lid. Okay, and after utilizing all the oxygen that is inside the lid, what is going to happen? The candle will stop burning because it doesn't have any more oxygen inside this lid. So we have oxygen freely outside but not inside, so the candle will stop burning. So that's why we need oxygen for burning. So we are providing the oxidizer also along with this fuel. So hope you understood about this propulsion system and oxidizer. So many things we learned. Okay, now let's talk about ISRO launch vehicles. So these are the satellite launch vehicles. Here you can see this is SLV-3. Okay, and here you can see the height is 22.7. That is the shortest ISRO launch vehicle that we have. And the payload mass is 40 kg. That is very less, right? So for ASLV, augmented satellite launching vehicle, so here you can see the payload mass is 150 kg. Okay, that is more than SLV-3, right? And coming to PSLV XL, here you can see the payload mass increased. That is 1860 kg, and the height also increased, that is 44 meter. Okay. And the propulsion system, in the case of ASLV, it is all solid. In the case of PSLV, that is solid and liquid, both we are using. And now we have this GSLV Mark II, and here we are using solid, liquid as well as cryogenic. And the payload mass is again more, 2200 kilogram. So GSLV means geosynchronized satellite launching vehicle. And here we have the same, that is GSLV Mark III. And the difference is it is the payload mass. Here you can see it can carry anything, any heavy payload, that is up to 4000 kg. And the height is 43.43 meter. So these are the various launch vehicles that we are using in India. So recently, a private company, that is Skyroot Aerospace, they also launched a rocket. So that is a first history in India where we are launching the private rocket. So that is Vikram S by Skyroad Aerospace. So now it's your turn to decide a reusable rocket. That is the biggest challenge. So all the best for that. Thank you so much everyone. Thank you for listening.
तो ऐसे फिलहाल तो हम लोग का ये वाला भी कंप्लीट हो चुका है भाई। 20 मिनट का था वीडियो, तो मार्केस कंप्लीट। लेट्स गो। ये भी उसका भी ये शुरू होगा, तो ये सब भी तो मैंने देख लिया है ऑफ वीडियो। मार्केस कंप्लीट कंप्लीट कंप्लीट। यार सुबह से बैठा हूँ लिटरली। लेक्चर पहले शुरू करते तो अच्छा होगा। ये भी कंप्लीट हो चुका है। अभी ये सब देखना है। 9 मिनट के लिटरली बज रहे हैं 12:23 है। मुझे तरफ नहीं आया। भाई अच्छा जल्दी ज्वाइन कर भाई, बोला ज्वाइन करेगा। पता नहीं वो आएगा कि नहीं। ओके फिलहाल तो ये भी शुरू करते देखना।
Dear all, welcome to our new tutorial dedicated to Autodesk Tinkercad 2021, an online CAD tool completely free to use. In just 9 minutes, we will see everything you need to know to start using it. Autodesk Tinkercad is a free online CAD tool for everyone. It is the best choice to learn CAD for the first time, but also a great solution to bring experiments and ideas into life with 3D printers. It is 100% safe to use for kids. To start working on Tinkercad, just open its page and perform a login. The first time, you may need to register any email address to create an Autodesk account. At this point, you can start building several kinds of projects, including 3D CAD designs, electrical circuits, or animations with code blocks. In this beginner tutorial, we won't see the circuits since they require basic knowledge of electronics. Select 3D designs and click on Create New Design to start. You will get a main preview with several buttons on top and other features on the right panel, which can be hidden if necessary. From this panel, you can browse for loads of ready templates, from basic geometrical shapes to 3D text, letters, numbers, character design, home design, and much more. You can also use the import button above to start from any 3D project you have. Let's start adding any basic shape. Just select it and place it on the preview with your cursor. To drop it correctly, you can right-click and drag to 3D rotate and use your mouse wheel to zoom in and out. Once the object is placed, you can click on it to select it and adjust its properties from the dialog box on the right, such as radius, smoothness, length, width, and height. You can also click on Solid to select its color and transparency level. You also have the Hole option, but we will see this one later in this video. Other templates can work differently. If you drop any scribble, the workspace will change in order to ease your brush on a 2D environment. You can always check its 3D result in the top right corner. At the bottom, you can use the erase tool to remove any brush and the shape tools to either brush or erase complex shapes by varying the current radius. Use Done to apply all and come back to the main workspace. If you see that the camera is not centered on the current object, use the F key. Select Text to drop any 3D text. Then adjust color, text content, and its font on the right. Other templates, such as the ring, give you the possibility to customize its section as you like. Now let's see how to edit these objects. Select any and click and drag it to move it. Consider that the object remains attached to the ground, here represented by the blue work plane. Tinkercad also gives instant measurements, starting from the dashed object base and taking the unit defined from Edit Grid in the bottom right corner. You can choose millimeters, inches, and also resize the main blue work plane if you need some more space. You can also move by holding down the Alt key to make fast copies from the current object. If you make any mistake, you can use the Undo and Redo buttons to undo and redo actions, or the Delete button to remove the selected object. You can also edit the object using its nodes. Hover over these to get instant measurements on it, and drag from these to resize or rotate. Use the white nodes to resize freely, holding down the Shift key to save the original aspect ratio, whereas use the black ones to resize through a single direction, and the black cone on top to adjust the height in respect to the ground work plane. You can also use the arrows to rotate through the internal or external circle to change the rotation snap. Also, when you move and resize, Tinkercad applies snappings by following the work plane grid. You can adjust these or turn it off by going to Snap Grid in the bottom right corner. You can also use the R key to drop any ruler. This can be useful to take any relative distance under control. The work plane is a very important element, fixing the reference plane to take when moving or editing. If you click on work plane and then on any object face, this will be taken as reference, becoming a work plane in orange color. At this point, any action is made by taking such new plane as reference, easing the design process and taking everything under control thanks to the blue projections on it. You can come back to the original work plane by enabling work plane and clicking on any empty space. As you start getting lots of objects on the project, you can manage these with the two buttons in the top right corner. The first one locks the object, preventing any modifications on it. The second one hides it, until you click on the light button above. Now let's see how to design complex object shapes. If you click and drag over the interested objects, you will select these all together so that you can move and edit these in the same way. If you also click on the group button, you will create a unique object from these. This allows to make complex shapes in case